Very much, Dan, and howdy everyone. It is an absolute pleasure to be with you all today for this partnership summit, and I'm very much looking forward to learning from the broader ecosystem and engaging with all of our community partners. As Dan mentioned, my name is Kelly Kiedis Ogborn, and I am President and Chief Operating Officer of Advanced Rockets Corporation. We are an aerospace company based out of Southern California and Washington, D.C., and we specialize in air-breathing hypersonic rockets for routine space launch and defense applications. And later in this presentation, I will be joined by Othniel Mbamalu, who's our CEO and CTO, to talk about some of the technical aspects of our launch vehicle. What I find extremely exciting about this moment in space is how fast it's growing and how broad it's becoming. And really, to benefit from this vibrant industry, it requires reimagining the space ecosystem itself. Dave touched about this in his presentation, but it's reimagining the ecosystem. And then really where we're focusing on is reducing the barrier of entry for companies that are looking to build and sustain the infrastructure of the impending economy in LEO, MEO, GEO, and beyond. So really pushing it to make it an economy of scale. And our role is to make space travel routine. We envision a future where the cadence of going to space is as ubiquitous as airplane travel. And we really believe that our hybrid air-breathing design makes that possible for a multitude of reasons. If either driving down launch costs through higher reusability or point-to-point capabilities, or increasing vehicle utilization and allowing for flexibility of launch, really not tethered by geography, timing, or trajectory. And collectively, when I think about this, we are extremely fortunate to live in a time where the moon and the Mars are no longer a wish, they're a fact. And while we still have a really long way to go to build out our collective wish for the space to Earth markets and the space to space markets, this community here is really defining the future now, which is very exciting. And our partnership with Arkisys, really solidifies that. We are extremely proud to be providing reliable launch services to both transport the wedges themselves to build the port, as well as the projects to be conducted on the port, really enabling their goal of the 90-day portal to launch cadence. I'm now going to hand it off to Othniel to explain how we accomplish this task for Arkisys.
There you go. Thanks, Kelly. Thanks. Like she said, my name's Othniel Mbamalu. I am the CEO and CTO at ARC. I'm thrilled to be talking to you today about how ARC is working with Arkisys to provide routine and reliable, affordable access to the port. I'll start with a broad overview of our flight path, give you a quick snapshot of our payload configuration, and then go through each critical phase of the flight in sequence. So let's get started. Here you can see a flight path, which may look a bit different from what you're used to seeing for a typical rocket launch, say. In order to maximize the efficiency gains afforded by our air breathing system, our vehicle will launch vertically and then ascend to around 80,000 feet and then fly horizontally like a plane until stage separation. This allows us to launch from and return to a huge variety of sites, providing a lot more flexibility for our customers in flight and on the ground. We are excited that our first payloads will be the wedges of the Arkisys port itself. We've been working with the Arkisys team to establish the best way to configure payloads, optimize space, as well as operational efficiency. This slide provides a brief overview of our solution. Our vehicle is rated to loft a maximum of around 27,000 kilograms in payload, which is quite sizable, and would have a sizable return payload as well. That number is not necessarily the mass of the payload we expect to carry on a routine basis, and that's to be noted. So smaller payload obviously would represent a higher delta V for the same propellant mass, which further reduces the need for another propulsion stage on OTV. We're looking at some of the implications and logistics for this at the moment, but the delta V for our vehicle, the combined delta V for our launch vehicle, both the lower and upper stage, is a sum of around 13,000 meters per second, permit me. And so given the required energy to orbit, we do have a margin of about 4,000 meters per second to play with. That margin is what gives us the ability to do things like incorporate a continuous intact abort capability into our vehicle. The second stage has this capability both from launch all the way to orbit, and the specifics of this could be discussed in the breakout session. It also allows for us to maneuver around weather. So we're not necessarily as subject to adverse weather conditions as most traditional launch vehicles might be. And we could also launch from less optimal locations for specific payload or specific target orbit rather. And as I stated, this is based on the maximum payload of 27,000 kilograms, which means carrying lighter payloads or low masses would allow for us to increase that margin even further. And I think the routine would be that we would actually operate with carry much less heavier payloads than 27,000 kilograms. The estimated launch cost is supposed to be at around $100 per kilogram. And the low price, the specific low price is due to our high reusability. We're actually estimating we're targeting around 400 reusers for our launch vehicle. And we are looking at a high utilization of about 2 launches every week and a very low cost for refurbishing the vehicle. And again, the details of how we are able to achieve this could be discussed at the breakout on the breakout session. What you're seeing here are the S-ring interface that will hold the Arkisys modules. We have multiple S-rings stacked in our payload fairing in this specific illustration. A key factor for our vehicle was the choice, a key design factor for a vehicle was the choice of a hybrid air-breathing engine. As a hybrid, there would be a rocket and an air-breathing system. For the first stage of flight, we have 2 stages. The choice for air-breathing is primarily based on obvious superior efficiency, the ISP and what have you. This, amongst other things, allows us to incorporate a lot of freedoms in the design of the vehicle. And the first stage, we're looking at a target ISP of about 2,000 seconds of ISP, and then the upper stage, closer to 400 seconds. The upper stage will be a pure rocket-based propulsion system. More efficient propulsion means less mass. That would be fuel and oxidizer, which means we can build our vehicle out of stronger materials with less concern for what the total mass of the vehicle might be as a result of that, and building more safety and reliability safeguards, if you like, and obviously carry larger payloads. In essence, our flight path and staging protocol is about finding a compromise that accommodates the needs of the customer on the ground while addressing the requirements of getting the vehicle to its destination. Our solution provides flexibility in launch, location and logistics in the first stage, but then reorients the vehicle to address the requirements and realities of delivering the payload to port in the second stage. Once the vehicle is in the right position for flight to its final destination, we're ready to separate and then complete the remainder of the mission to orbit. So we've talked about we're separating at a relatively low altitude of around 80,000 feet. This is compared to most rockets, which typically separate anywhere from, I think, 190,000 feet to 260, 60 to 80. kilometers. So separating at low altitudes and Mach numbers makes it much easier to return the first stage, as well as allowing for us to reuse it many more times than would be possible if we're doing a high energy missions or what have you. The first stage flies back, and we expect to do a vertical landing. From that point, the second stage continues the rest of the mission to orbit. We believe that a space economy, this is critical, and for the space economy to experience the rapid growth that we need to see, or we all hoping to see, there needs to be a significant improvement in the reliability of some of these systems. And we need to start inducing the same kinds of confidence as commercial freight airlines might. I'm going to discuss CIAC briefly, but in a nutshell, it allows for our launch system to be recovered from an in-flight anomaly. I believe the space shuttle actually had this design into it. We were working with some of the engineers who actually worked on the space shuttle on some of those design parameters for our vehicle. And we want to be able to recover payload or the crew, most essentially, during an in-flight anomaly that might otherwise lead to the destruction of a vehicle. Our orbital maneuvering system in the second stage gives us flexibility for orbital operations, but also serves as part of our emergency contingency for both port and other space assets. After carrying our payload all this way, the last stage of the journey is, of course, docking at the port. We'll be using industry standard docking procedures and interfaces, as with most things, reducing the number of events and new systems, what have you, reduces both the risk and cost for developing, operating, and deploying these systems. When docking, I think this is sort of the final piece here. When docking, the payload fairing opens up and is able to swivel up to 180 degrees, potentially more, which provides clearance for the vehicle to dock to the port without any obstructions. So these are some of the details of sort of surface details of the vehicle and launch system we're working on and designing. Thanks for your time. I'm gonna hand over to Kelly. I'm looking forward to talking to you guys on the breakout session. Thanks.
Thank you, Othniel. So what Othniel just showed was the specific ConOps trajectory for an Arkisys mission example. We would love to hear from you in the chat if you have any specific examples around, payload configuration, cadence requirements, or any sort of special missions. As a next step for us, we are working on creative solutions for precision reentry vehicles for sample and cargo return to really create this circular economy. And we've been discussing with Arkisys how we can best do that. So we look forward to talking in the chats. Thank you.
Kelly, Othniel, thank you so much for that first presentation. And I'm excited to have everyone at the end of our presentations get into breakout rooms and have an interactive conversation. If you want to learn more about the launch capabilities of the rocket platform, please do hop into that breakout room at the end of our sessions. Up next is a good long-term friend and colleague and co-conspirator, Jörg Kreisel. He is going to be talking a little bit about something very critical to our infrastructure as a whole, the idea of interfaces. It's a hot topic, even a curse word in some arenas, but we'd like to open up a really fascinating discussion about intelligence-based interfaces and how that's going to unlock potential on the port. Thanks, Jörg, go ahead. Jörg, I think you have to unmute.
Yeah, okay, I hear you. Can you hear the presentation? First slide, okay?
Yep.
Okay, so hello everybody, thanks for having us. So it's my pleasure to talk to you about the ISSI, the Intelligent Space System Interface. And it's me, Jörg Kreisel. I'm a co-founder and chairman of company IBOS. And there's also here Thomas, our CEO and a tech lead. And we will be happy to talk to you later in the breakout rooms. So let me give you a little tour. I have 10 minutes and then I gotta go, but we will be back with you later. Thomas is around all the time. So what is this all about? Interfaces have been talked about for many years, and so we are a small company from Germany, and we have fortunately managed to kind of get some attention for our interface technology. The ISSI, let's start from the other from another angle. We believe, and that is potentially also the whole idea of Arkisys and the port, space infrastructure and social logistics, that's the next big thing for space. So all of the topics here, the big themes for space, and of course the port ties in very well as a kind of a super payload pathfinder something to all of this. These are things which on the long run will involve more and more modularity and interfaces, and will be supported by OSA, on orbit servicing, assembly, and manufacturing, and so forth. And our interface is meant to support all of this. So what's our mission? Our mission is to provide the USB for space, to let others, and you and the port, do Lego in space. So we are not. It's not a kind of an adapter for rockets. Well, it could be an adapter for payloads, but it is primarily an adapter to enable ultimate plug and play in space to connect modules of any type on the ground and in space. So that's our mission, to do that. Here is a first impression of our hardware, what it looks like, and now let me take you to what we want to do and what we can do and what we are out to do. So if, in generic terms, if there's two modules you want to combine, there's a couple of generic integration or connection issues, so. And generically, we're talking about mechanical connection, a power connection, data connection, a thermal connection, fluid transfer connection, gas, or even objects. An interface could even be something where you put an object through, right? So, and those interfaces exist. So, our interface caters for the first four: mechanical, power, data, and thermal. And how do we do that? Here is a kind of a CAD overview of the interface. So again, the name ISSI or ISI stands for Intelligent Space System Interface. And it's all for, it's this USB for space as we want to make it. And it's, first of all, it solves the integration problem. Right? It saves time for AIT on the ground, and it is good for any building blocks and robotics. And that is what the port is all about. And a couple of other partners around the port playing along the same lines. So key features are, besides the multifunctionality, mechanical, power, data, thermal, it's the entire system, little interface system, is fully modular. As far as the functionalities are concerned, it's also scalable in size, but we have a baseline now, but you can also scale up the various functionalities. It's heterogeneous, so it means like there's no male, female, two same parts connect. It couples very fast, it has a fail-safe system for decoupling. If one side breaks, it can safely decouple. It is of 90-degree rotational symmetry, which is good for robotic mating and so forth. It has a flat surface, which is an unrivaled benefit. It provides multi-mounting options. You can mount it from the sides, from the back. It is a lubricant-free mechanism. It's very compact, light, and the technology is patented at international level. So, in essence, what is it here? I talked about the functionalities. Here you see hardware. We have produced quite a lot of those, more than 100 units. It is fully modular, it's compact, as you can see. It's about in the 5.4 inch range. It weighs round about a kilogram, the core unit, and it is coupled fast with adjustable speed. On the left hand side on the photo, you see the flat surface, and it's basically a disc, and on the right hand side, you see the power pins coming out, which also supports alignment, but then later transfer the power up to 5 kilowatt at 100 volts. So what can we use it for? And I don't think that I need to explain, or we need to explain, any one of you what to use it for. There's many coupling and connection things. Most of them are listed here. The pictures may give you an idea. What is probably worthwhile mentioning is for systems on the ground, it solves the late loading issue. but also for robotics. It provides an end effector, but potentially also a robot foot for walking robots and other stuff. And the pictures kind of suggest a number of other things, and I'm quite sure that many of you have looked into these type of things, so it can potentially serve as a multi-purpose connector. Let me show you how it works. And so here it gives you an idea. The motor drives the central mechanical connecting unit. The power pins come out. When the other side gets close, it supports the alignment, you know, then the mechanical thing comes in, it pulls back and then makes a rigid physical connection, you know, and the power is being transferred through the pins. On the right hand side you see the same thing from a different perspective, and you see a very sophisticated mechanism then pulling back in when the thing decouples. And of course in the center of this there is a high-speed data interface, and we have a redundant CAN bus interface. So it's two data interfaces, and a mechanical and a power interface. I hope that gives you an idea on how the ISI works. And here is again a view on the core unit. The core unit is in most cases a 3-in-1 connection, which is mechanical, data and power. On the left hand side the hardware, on the right hand side again the CAD overview. So you see the high-speed data interface in the center, optical. You see optical CAN bus interfaces here around, it's redundant. The data interface goes all the way up to 10 gigabit per second. We have currently a baseline in place with 1 gigabit per second, but we can scale it up, and we have already started in testing. So yeah, electrical interface is here kind of retracted. The pins are retracted into the purple sections. You see the motor and get an idea. Most importantly, the whole interface is of a fully modular design. So on the upper left, you see the core unit, which is the baseline, a 2-in-1 or the 3-in-1 interface, so mechanical power data. And that comes as an active interface, or in some use cases, it suffices to have a passive interface, right? And that weighs only 200 grams or even less, where the active core unit weighs 1 kilogram. Then we have add-on modules for increased loads, misalignment tolerances, and diagonal engagement. You know, that is the form fit on the left-hand side, which can be customized to any use case. We have a thermal interface as an add-on module and a dust cover for planetary applications. But even the baseline is of modular design, so the motor unit, for instance, can be exchanged easily, you know, for testing and lab activities, a cheap Earth motor, and then you have for the flight or qualification model, you have a more expensive space motor. We have alignment pins for certain use cases, which you can use as an option, but also the data interface can be exchanged depending the transfer rate or the protocol used. That should just give you an idea. So what's up next on the horizon later part this year? This interface is being qualified aboard the ISS in the course of a US mission being conducted by SkyCorp. And SkyCorp is also partner to Arkisys and the port. And it's a mission backed by the DIU, NASA, and the ISS National Lab. What is important for us, since we are looking into OSAM at a larger scale, we have worked for a long time on mastering a production process. So we have worked with our partner Hegemon and other companies in the aviation automotive industry to master a process of Industry 4.0 process of manufacturing. So all this is in place, and we have, of course, kind of produced several higher lot sizes to make sure that we get to the quality level we want. So by the time we roll out the commercial space product, we want to have all this in tune. What is it where the ISSI supports the port by Arkisys? Here's a couple of examples, and when you have a closer look at these fantastic videos and the graphs provided by Arkisys and the rendered stuff, you see, if you zoom in, you see where our interface is supposed to sit. Where are we? What do we have accomplished? We are TRL 6. Hopefully later part this year we are 7 or 8, and next year we want to go through a delta qualification and to go for the final commercial product. We have end-to-end demonstrated this several times. The ground testing for the flights experiment is over, and we have done a couple of other good things. Yeah, and it's baseline for Arkisys, which is great. We also have Terrestrial Products. The company itself was founded back in 2017. We have patented technology. We have produced a number of units. We were the first international of Converse. And there's a couple of other things we're quite happy about. And then you also see a couple of terrestrial applications. We're working with Ford Motor Company on using this as a smart trailer coupling device for the F-150 and a couple other things. We are also quite happy and proud that several studies and players in the US have identified our technology is critical for OSOM and future orbital infrastructure systems. And last but not least, let me summarize by kind of pointing you at the major features, and the main takeaway is that the ISSI saves time and cost. It solves the integration problem, and it enables modular architectures, which the port by Arkisys is per se. Yeah, it's modular. It has a flat surface, which is unrivaled. It has quite good transfer rates, and so we hope we can get to the next level with all of you. And so anybody who develops kind of payload modules and other stuff to be connected to the port and to other infrastructure units can potentially use this. Yeah, that is, and it saves a lot of money. And as we use it more, the interface gets even cheaper. So later part, Thomas is in the chat in the meeting right now. He is in the middle. Here's our CEO, and he will be there. So answering questions around tech. I will be happy to talk about partnerships and the business itself. And yeah, that's more or less the end of our little tell. There you see another founder, Kai, who is a famous head of an institute based out of Germany. Here's a couple of data and contact points. So I'm sure that Arkisys will provide this later on. So thanks. That is the end of my little tell. And yeah, later on we will be happy to answer questions.
Jorg, thank you so much. That was exciting, and hopefully that is now starting to get people thinking a little bit about how the port and interfaces are going to interplay to scale different services on the port. And do look for Thomas in the interfaces breakout room towards the end of the session.
Thomas is here. He raises his hands because I got to back off. I'll be back in half an hour. See you guys later. Thanks for having me. Thank you very much. Bye-bye.
All right. Up next, we have Scott Herman and the Cognitive Space team. I'm going to hand it over to that crew, and off we go.
All right, Dan, can you see my slides okay?
Yeah, excellent.
Okay, perfect. Hey, everybody. Good morning, good afternoon, good evening, wherever you're coming in from. My name is Scott Herman, and I'm the CEO of Cognitive Space. And what I'm going to be talking about today is a little bit different. You know, we've been putting a lot of focus on how you get payloads to the Arkisys and how you integrate with Arkisys. I'm actually going to talk a little bit about how you operate your payloads while you're on Arkisys. And we're going to put particular attention against the idea of how do you do remote sensing from Arkisys. So if you're, you know, building a visible light sensor or a SAR sensor or some other kind of, you know, phenomenology, remote sensing, sensor, how will that actually work? How do you do your collection planning and your mission execution while living in a, you know, a shared environment with others? So we'll talk about that a little bit. We're going to give you a live demo of some of the simulations we've been doing with Dan and his team about how this might work. But first, just a little bit about us. Cognitive Space is building a set of software applications that can be used for satellite mission orchestration. And we really focus on three areas. One is managing your day-to-day, hour-by-hour, minute-by-minute satellite operations and collection planning process. And how do you optimize that so that you're doing the most effective collection, you know, servicing the most customers, capturing the most targets, interacting, you know, with Arkisys effectively. We also do forecasting, and this is the idea that as you build out your constellation, whether it's a set of payloads that may be running on multiple Arkisys ports, or maybe you're using Arkisys as a way to test your Pathfinder missions, and your goal is to build your own constellation over time. We help forecast, you know, what is the build out in terms of satellites and capacity, and how does that look year over year as your constellation grows. And then finally, we focus on orchestration. And this is really important to some of our government customers, where they're trying to scratch their heads and figure out how to deal with all these new commercial satellite services providers and orchestrate across the ecosystem. So how do you do collection across multiple constellations and multiple phenomenology if I'm monitoring a facility, I may want to watch it several times a day with a combination of electro-optical and SAR and hyperspectral and RF and methane detection. Pick your favorite. So we're focused on all those missions. We do that through an AI ML powered analytic engine that runs very, very fast and allows you to do dynamic replanning while still finding that best path, that best optimization, both for performance, but also optimizing for revenue. And what that means is we pay special attention to your business rules. How do you prioritize your customers? What kind of collections are you doing? How do you maximize against performance and revenue and make those trade-offs on every single pass, but over longer spanning collection campaigns as well. So what we're going to talk about today is a demo scenario with an Arkisys port that's up and operational. It's flying multiple remote sensing payloads. The idea here is that we have at least 2 remote sensing payloads on a single port. And so they have to work, independently. They each have their own mission and their own, customer focus. But at the same time, they're on the same platform. They're sharing that ride over their set of targets. So what we're showing is 2 independent sensors. They're both gimbaled sensors, which means they can point to their target. That also means we have to factor in things like how long does it take to slew, to look at a target and settle in so you don't have jitter off the platform. And you'll see that a little bit in the live demo. So think of 2 different sensors, 2 different phenomenalities pointing potentially in 2 different directions off the same platform, off the same Arkisys port. And we're trying to optimize that across multiple targets, multiple customers, multiple payloads, multiple organizations, and putting in real world constraints like what's the memory usage? How much can I collect before I have to downlink? What is my power consumption and how do I work with Arkisys to get the power I need, especially if I have an active sensor like a SAR. And what we're doing is we're looking at a series of regional point target facilities that we're going to fly over. So this is a real world scenario where I may want to collect against open pit mining operations, container ports, airfields, military installations, and you'll see all that in the demo here in just a minute. I'm going to actually turn it over to Dax Garner, who runs our aerospace team, and he's going to walk you through the details of the demo and what you're seeing.
Hello, everyone. My name is Dax Garner, head of aerospace. Before Cognitive Space, I spent about 10 years working at NASA Johnson Space Center and doing lots of guidance, navigation, control, algorithm design, as well as embedded flight software, and then tons of simulation software to support all of that flight software development, particularly for human spaceflight, the Orion human spaceflight vehicle. I also had a stint doing the same types of things for the Alpha rocket at Firefly, just to give you a little bit of my background. So what you're looking at here is a demo we put together for Arkisys. You see my understanding is that the orbit's going to be, or the first orbit's going to be about 180 degrees out of phase of the ISS, which is why we have the ISS modeled here. And the target set, like Scott was mentioning, is a real world kind of target set that you would have Earth observation payloads, be interested in making collections over. And since all these payloads are on the Arkisys, they have to coordinate how they're going to collect all these point targets as they're coming up over them. And you can go ahead and play the demo, Scott. You'll see the Arkisys vehicle come up over the horizon here in a moment. Oh, we also have the KSAT ground station here in Singapore to showcase coordination of ground link opportunities. So what's happening here is the blue dashed lines means that the payloads are making choices on targets to collect. You see the 2 different blue lines indicating the 2 different payloads that we have modeled. One's an E electro-optical, the other's a SAR. As it makes the selection, you see the green vector, slew over to the target, and then a cone that indicates that the payload's active and making the observation. Once it's done observing, it snaps down a footprint onto the surface of the Earth, showing the expected collection footprint of that target. Here's a zoomed in picture of what's happening there. And so, yeah, then you also have the white line there doing the concurrent ground link back with the KSAT ground station. And so that's really demonstrating our multi-payload capabilities and how Arkisys would use that to coordinate mission planning between payloads. The second demo is showcasing our multi-constellation capabilities. So we're not just simulating Arkisys here. We also have the Skyloom geosynchronous satellites constellation out there. And the point of them is, if you don't have the KSAT ground station to talk to as you're flying over, a set of targets over the Southeast Asia area, but you still need to be in contact and do coordinated mission planning between all these payloads, you could, utilize the Skyloom constellation to be in constant contact with Arkisys. You can go ahead and play this. So what you see, again, the same type of scenario. Arkisys is going to come up over the horizon on the target set. Once it starts making collections, it coordinates a comm link between Arkisys and Skyloom, one of the Skyloom satellites, which always has access to a ground station that we put over in the Canary Islands. As you can see, the communication link between the two there. I also forgot to mention earlier, on the right-hand side, you see memory usage. So that's us tracking resource data storage between picking up targets and downlinking them to Skylink down to the ground station as well. So including those factors into the mission planning. That's the demo that I had to show.
Yeah, thanks a lot, Dax. Really appreciate it. And we have deeper demos. If you join us in the breakout rooms a little bit later, we can go into some more detail. The visualization is kind of giving you the concept, but the real power is in the analytic engine that's actually doing the target selection, balancing all of the resource constraints, and helping establish the comm links to get that data back down to the ground where it's useful. So we're really happy to talk with partners that want to put remote sensing payloads on Arkisys, whether as pathfinders or full-scale operational, potentially revenue-generating sensors, or if it's the first step towards your own organic satellite constellation. We're definitely interested in talking to you about it. I think one of the things that's really different about what we're doing is this idea that processing orders and dealing with feasibility and doing executing the collection plan is a lot more than simply orbitology and physics, right? It's about the business rules that your organization wants to put into place to be able to manage competing customer interest, competing collection modes, and dealing with the realities of resource constraints and space physics and weather and everything else. We are doing this across a range of sensor types. We know that collection is very different depending on whether you're doing SAR or optical or RF or hyperspectral, multispectral, pick your favorite. And so we understand the complexities that may come with different types of sensors. There are web-based interfaces, but probably way more important for this ecosystem is our API interfaces, which will allow this capability to be embedded into your own ground systems architecture. That's super important. Don't think of us solely as an off-the-shelf, we do everything, although we're happy to talk to you about that. But think about us as an embedded component of your existing plan for your ground systems architecture. So how can we optimize what you're doing in terms of collection planning and mission execution? And I think we can have some pretty interesting conversations there. The other thing that we're doing is really building for scale, right? We're entering the world of small sats and mega constellations and constellations that may have dozens and dozens of satellites. You may have multiple payloads across the Arkisys network, and we're really designing for that and orchestrating collection across your fleet of payloads rather than treating each one as an individual special snowflake that you're interacting with one at a time. So I hope that was useful. You can find us on the web at cognitivespace.com. There's a lot more information there about what we're doing, and we'll see you shortly in the breakout rooms. Thanks a lot. Back to you, Dan.
Thanks, Scott. Dax, Scott, well done. That is a great illustration of collaboration between our partners and glue technology in essence. So do hop onto a breakout room to interact with the cognitive space team after our demos here. And on to our next, the venerable Dr. Heath Mills from Rhodium Scientific is going to discuss how they are partnering with Arkisys to help stand up something I think is extraordinarily important to the business of science at the port. And with that, with no further ado, I'll turn it over to you, Heath.
Howdy, everyone. And no matter what time zone you're in, I agree that that greeting works out pretty well. So thank you, Dan. Thank you, Dave. Thank you, Arkisys, for setting this up today. And it's been a pleasure hearing everybody else talk earlier and looking forward to those that are following. And I hope everybody sticks around for some of the discussion and breakout groups at the tail end. Looking forward to talking with everybody and hearing your ideas, hopefully answering questions. And as this partner workshop was designed to do, hopefully making those good connections. So for our part today and at Rhodium Scientific, I want to explore a little bit more into the science that can be done, should be done, hopefully will be done on the Arkisys port. And at Rhodium Scientific, we really want to put that "and" in that title that I have there, the research and development. It's great to do research, it's great to discover new things, but we also want to put the "and" in it so we produce something at the tail end of it, produce that product. And we feel that with Arkisys and with the team and the systems that are being developed, there is a good chance that we can explore and build something from this new environment. So with that, give you a little bit of background to Rhodium, and I'm going to start on a very broad level, and I'm going to work it all the way down through this brief presentation as to the why we are doing what we're doing and why we feel that space is important. But who we are is Rhodium Scientific. We do provide that turnkey solution to doing science in space. We are considered a commercial space biotech company. We are science first, and I'll explain more of that in a little while. The company was founded in 2014 by Olivia Holzhaus, who is our CEO and founder. We are a woman-owned small business, and we work with a wide range of different scientists through different fields. But in 2016, Olivia made the very big, bold decision to pivot the company towards space. And since then, we have built a pretty well-rounded track record and a good history with flying with different companies, with working with different projects to get to space with that science operation focus. And to do that, and over the time, we are focused on having access for not just one industry, but different industries. And that is through academia, that is through the commercial side, as well as with government partners. We do open up different access points, and today we are focused on our access point with Arkisys and why to go into and why to go to the Arkisys port. We provide unique services within this industry, and those are to help develop that mission, that science relevant mission. We can step in and work with and partner with or assist, depending on whatever level you need, to develop your project, to manage that science project as it goes through, and help you answer and adjust to the different questions and hurdles that are faced with taking your research, your product development, your industry into space. We do this with a level of quality assurance that is recognized by different industries, that commercial markets, your investors. We make sure that the projects are managed in a way that that product that is produced at the tail end is valid, it is valuable. And so we make sure that these quality assurance protocols go forward. Now, in the process, in the last few years, we have developed some of our own flight hardware. This flight hardware has already flown on the International Space Station. We do have a facility there. It's called the Rhodium Science Chambers that support different types of cellular growth, from human mammalian cells to microbial fungal cells. We also have developed an interesting and unique temperature logging device that measures both temperature and humidity. But for this, and for a lot of those that may be out there listening right now, we also have the capacity to help certify new hardware. And that's where coming into and moving to the port is important. One thing with the way we certify and the way we can team with you is the certifications also have that science first mentality to it. It's great to build something, but if you're building it for a science community, we are the science community and we can help add an interesting voice to that development and that certification process. Now, I've said science a lot, and I said we're science first, science strategy, science focused. That is where we come into this environment. We are there to work with you through that project translation phase. You're really good at doing your research, to doing your science work on Earth, in your lab, in your facility. What we want to do is help you translate what you are known for and what you have accomplished in your home environment to the new space environment. And that's where that project translation comes in. And that's where working with a team of advanced degreed scientists can help provide a unique perspective to your overall development strategies. We will work with you on those. We will help develop those. And we do that also with the unique process that we developed with the Department of Defense, the quality industry compatible quick space process, because we understand that doing things fast is important. The speed of business is important, especially in the biotech industry. The speed of business is very important to understand. We also want to do it well, not just quick, but we do it quickly and accurately. And so we'll help monitor those quality assurance metrics all the way through the flight operations. We've had multiple successful missions in 2020, and we all know what 2020 was like. But even through the pandemic year, we were successful and got multiple flights to go to the ISS. We see these as seed projects with what then can be branched out and brought now to the port. And that's what we want to help you understand is what can go into that direction. So with today's talk and with today's focus, and hopefully you'll go to the Arkisys website and start understanding that onboarding process to get you to the port. We provide a unique complementary parallel pathway for what the Arkisys team has developed for the onboarding process. And that is, if you have science in your project, if you need science support, we will work with you to navigate that timeline, that pathway to get to space. We'll help you with that project development, that science integration, work with you through those pre-flight testing and requirements that are put forward to ensure that your project acts and operates the way you expect it to. That's the help, and that's the services that we can provide through the project development science integration phase. So you see us as that complementary parallel pathway that makes this very rapid, very cool onboarding process that Arkisys has set up functional for the scientific community. Now, I'm mentioning science community, I'm mentioning this, and we haven't gotten into a lot of why go to space from the science side. And so for these last couple slides, and if you join me in the breakout group, we're going to talk about some of these in more detail. And hopefully some of these resonate with the work that you may be doing or you're interested in. But say from a biological perspective, there's certain whys of why go into this environment. In space, biology experiences novel physiologies. How the cell, how the organism operates in space changes from what happens on Earth. There may be shifts within the genotype, the DNA, the chromosome, the molecular level may change as well when it gets to this new environment with new stressors. And there's also some functional advantages, especially within the area of, say, 3D cell culture or bioprinting, that allows for a better product to be produced in space that can't be produced when there's gravity present. So within each one of these, moving these and understanding what's been done in space prior, moving those into the Arkisys port allows new industry to now become possible and even scalable. Whether those are drug production, discovery, biomanufacturing, biofabrication, identifying new tissue culture, tissue engineering areas with stem cell work. Each one of these, we're either currently working on projects, we're developing programs right now at Rhodium to address these major global challenges, or we're looking for you to come up with those new ideas and partner with us and work with us to address major global challenges. Now, biology, I'm a biologist myself. I'm an extreme environment microbiologist, so I am fond of the biological side, but also chemical environment and the chemistry that happens in space is different than on Earth. Due to that density, that lack of gravity, that density deposition, that convection doesn't happen the same way in space, doesn't happen there. So that changes the way chemical reactions proceed. Combustion is different. You can do contactless processing because you can suspend an object or a reaction without any interactions with the vessel itself. You can also have more uniform microstructure formation. And on the right, you can see different fields, different markets that are directly applicable to doing work in space that may not be reproducible on Earth. And again, that scalable side that the Arkisys port offers is a unique environment. Now, we have had some conversations already about the physical environment and that unique vantage point of doing work in space and looking back on Earth. Different gravitational potentials and accelerations can be tested on the Arkisys port. You also have that unique environment and access to space itself with different radiation environments, the gravitational environments, the vacuum conditions. Each one of those has led to different tests, different initial early on production areas of the markets that you see here on the right. These are areas where we want to help you expand and explore and find out new ways to kick off this new economy, this new environment. And as was mentioned earlier, this is an environment. This is an environment that needs to be utilized, understood, and used in this case to develop new products. So I've kind of said some of these, but I wanted to put these forward. And again, I want these to be conversation starters. I want this to be things that we talk about within the breakout group, or you go back to your team and talk internally about and start finding those resonating points to come back. Let's build the synergies. Let's build the partnerships that this workshop is designed to do. So the port does have unique advantages with, like I said, scalability. It is a new path to space that goes away from some of the earlier barriers, the timelines, the constraints to operations that are currently hampering some of our productivity that we're having within the low Earth orbit environment. The Arkisys port is solving these. The autonomous vehicles with those restrictions that you may have a chemical reaction or a biological reaction that's not suited for a human occupied environment. We can do those now on the port. And I really appreciate the discussions that we've had already, the talks that we've had before about that fully functional plug and play environment. We start getting that plug and play R&D in space where we can test new things, we can identify new tools, new solutions. Let's do those for those science markets. And we're looking for partners that are building new hardware that can help support the science clients that we have right now that are wanting to go to space. We can talk with you about new engineering opportunities, new hardware that we may be able to work together on. That's where this partnering can really help out and get the science community up and running. So it's with that I really thank you, everybody out there right now, especially the Arkisys team, for allowing us to come and do this and to be a partner with you guys. It's been fun working with and helping develop this area, and the science directorate on this. Please add questions and comments to the chat window, and I hope to see everybody in the science breakout room coming up shortly. So with that, Dan, I'll turn it back to you, and thank you again, sir, and I'm looking forward to the rest of the morning here.
Thanks, Heath. Again, if anyone has follow-up questions with, there's been a few in the chat. If anyone does have questions here for Heath or any of the Rhodium scientific team, please do hop into the breakout room. It is always enlightening to understand what you can do in space, talking to Heath on the science side. With that, I don't want to delay here. We have a tight schedule, so I'm going to turn it over to Yusuke from Gitsai in Japan. So think about the time zones here. That's a pretty brutal one, but he's been gracious enough to attend our partner summit, and we're going to attempt to do a demo here as well, and discussion of Gitsai's capabilities. So with that, I will share my screen, Yusuke, and off we go. One moment here while I do that.
Okay, thank you for the introduction, Dan, and howdy y'all, and thank you for participating today from on the other side of the planet. And special thanks to Arkisys for giving us this opportunity to showcase what capabilities Gitsai can provide to support everyone's business on the port, whether it be science, R&D, or anything you want done in space. We'll provide the labor to get it done. And hey, okay,
Do you see the notes or do you see the actual slides?
we're seeing the notes.
All right, let me see what I need to do here.
Yeah, while Dan's working on that, our company Gitai is developing highly dexterous and versatile robots to provide a more cheaper and safer way of getting things done in space. And,
All right, here you go. I had to just kind of change my configuration here. Okay, Yusuke, are you seeing it now?
hey, it looks good.
Okay,
Thanks,
great.
Dan. Okay, and here's a few images of the robots we've been developing. And a picture is worth 1,000 words. In a video, much, much more. So let me go straight to showing you what Gitai's robots can do. And basically everything I'm gonna show you is real, not computer graphics, and running in real time, not 10 or 20 times faster. Oh, I think you went too far.
Too far.
One slide. Ah, that's it. That's looking good. Okay. And I'd like to first show you our remote controlled or teleoperated robot, the G1. You see here how the robot is working with soft objects, which is extremely difficult for autonomous robots to handle. And you see here how the operator is controlling the robot with the Gitai design manipulator. And you see on the upper right here, on the top or the whole screen right now, this is the actual image that the operator is seeing through the two fisheye lens on the robot for stereoscopic imaging. And we designed this robot, and because we had in mind of providing a general purpose robot that can support, not replace, the astronauts on the ISS. That's the humanoid architecture. You see it flipping switches, pulling in and out cables, daily chores that the crew, the astronauts do on the ISS daily. And here you see the robot working on an experiment called the mouse habitation unit in the Kibo module of the ISS, the Japanese experiment module. And this was one of the tasks that JAXA wanted to automate because it takes a whole lot of crew time for one experiment to complete, about 80 to 90 work hours. So we actually did a few operations related to this mouse habitation unit. You see here the robot handling tools designed for people to use, a screwdriver. And you'll see it nailing it down exactly on the nut. So you see the precision that the robot has. And this was an example of our teleoperated humanoid robot with high versatility. And okay, so we have a robot that works nicely on Earth, but will it work just the same in space? Teleoperations is cool, but how are we going to handle communication latency? Any autonomy? And we're aware that we have to answer all these questions to really become a space robotics company. So actually, we're sending up our robot to the ISS this August on SpaceX 23, and we're going to have our first in-space tech demo there. inside the Nanoracks Bishop airlock. And this tech demo will be comprised of 2 experiments. The one you see here, it's working on intervehicular activity or daily chores that the astronauts do inside the ISS every day. Everything you see here is done with almost full autonomy, or we call it supervised autonomy, where there is some space for human recognition. And for the operations of this robot, what we do for the actual operations is through the motion planning system that the robot has, the operator will be able to check what the robot will actually do if the robot proceeds with an action. And if the operator likes what he sees, he'll give a go or no go, and the robot will proceed with the action. And that's the extent that the operator will give any commands to the robot. And the actual motion and the action of the robot itself will be done through autonomy using the image recognition system and the markers, which is the Gitai logo you see on this panel right now. This robot also has some force feedback, so it can fine adjust its position when it's doing very precise motions like pulling in and out cables. You saw before how it was able to put back the Wi-Fi cable, the LAN cable, and the USB cable back in its position. And if it might be off by a few millimeters or so. So with the force feedback, it'll be able to adjust, fine tune its position so the cable will fit right in. And oh, if you could go to the next slide, yes. This video will be running very, very fast because the operations take very long. But the second part of our tech demo, we will do some on-orbit servicing tasks, especially an assembly task, to put together small pieces into a structure and add panels to it that resembles like an RF antenna or solar panel or a mirror, telescope mirror. This is also done all autonomously using the fiducial markers that you see all around the platform. We wanted to show the industry that our robots have the capability to conduct OSAM tasks, on-orbit servicing, assembly, and manufacturing tasks in microgravity. And for this tech demo, we will do everything under the pressurized environment. So we're aware that it's not completely in space. So we are planning our next tech demo outside, exposed in the space environment as early as the end of 2022 or within 2023. Even without the teleoperations, you see here the high precision that the robot has working autonomously and able to handle human designed tools. Okay, and if you can go to the next slide, please, Dan. Yes, and to add on, preparing our robots to be space compatible, we have 3 other exciting projects going on, and let me touch on 2 of these. The first one, JAXA has come up, the Japanese space agency, JAXA has come up with a mission to conduct the first active debris removal mission in the world. And the mission is divided into 2 phases. phase one is to acquire in situ data of an upper stage of a Japanese rocket that was launched about 10 years ago by the end of Japan fiscal year 2022. And assuming that this phase one succeeds, the mission will proceed to phase two, where we will actually rendezvous, capture, and remove that upper stage. And this service or satellite is planned to launch no earlier than fiscal year 2025. And an honorary servicing company. I'm not liable to exactly say that company name, but I'm sure everyone can assume who we're talking about. But Gitai, we have been selected to be the official partner for the robotic debris capture system and to design the robotics for the capture mechanism. This is a 2-year joint R&D contract for 1.4 million US dollars. And we're actually, we have a video of the ground demo of the actual robotic arm capturing the mock-up of the payload attachment fairing of the rocket we're planning to capture, but unfortunately, I'm not allowed to show that yet. And if you can go to the next slide, please. Yes, the other exciting project we're working on right now, Japan has announced its official participation in the Artemis program, going back to the moon. And one of the largest contributions from Japan for the Artemis program is planned to be a pressurized manned lunar rover, also known as the Lunar Cruiser. And Toyota, the automobile company, they have been chosen to be the prime contractor to develop this lunar cruiser. And for the past year, we've been conducting weekly meetings with Toyota Research Institute and JAXA, conducting thought experiments, working on paper to come up with the requirements. And we are currently working on the details of the contract to start development of our robotic arm and to conduct a ground demonstration of the whole lunar cruiser within this year. And we haven't yet sent our robot to space, to the full space environment yet, but we're already working on projects that require that. And we have already built our robotics to be space compatible already, not just sent it up yet. And yep, these are the things that we're working on, and hopefully we can provide these capabilities to anyone who's planning to use the port, and hope to talk in more detail with everyone in the breakout rooms. Thank you, Dan.
Yusuke, excellent presentation, very exciting progress with the robotics and the robotic arm. As you can see, what Arkisys is trying to do here is demonstrate the relationship between a myriad of different technologies that in concert create a dance in space. And we are able to do really the next logical step in capabilities. And so do reach out to Yusuke in the breakout room. We will be having a additional series talking about our interfaces and robotics later in the fall. Stay tuned to that. And so again, thanks again, Yusuke. And on to our next presentation. I'd like to welcome, who do we have up next here? I think it is Ruben from KSAT. So again, thanks, Yusuke, and off to Ruben. I'll hand off to you. Ruben, I assume you're going to drive as well.
Thanks for the introduction, Dan. Yes, I will be driving here. Let me pull up my presentation. All right, please let me know if you see just this slide and not the one with the notes. It is clear. Great. Well, thanks for the introduction, and it's exciting to be here with the rest of the companies. I would say it's a consortium contributing towards Arkisys port, and it's very exciting. And I just wanted to thank you and everyone else that has been on this call, and it's very exciting presentations, and looking forward to the future for this. And where we come in as KSAT is we focus mainly on the telecommunications side. So who are we? We're based in the north, but our company has a global footprint. Our unique location within the Arctic Circle is the perfect starting point for space-to-ground communications and fast access to satellite data. We're a company that knows and cares about space. So through our leading position in the space industry, we have built long-lasting relationships and fruitful partnerships across the globe. And we're always exploring new technologies and solutions that are taking us from LEO to the moon. We've provided data acquisition and TT&C services for more than 50 years. And over that time, KSAT has proven the value of being a top-rated partner. We're proud of our legacy and excited to continue innovating with advanced technologies to meet customer requirements with regards to flexibility, resilience, and speed. That is our main priority. KSAT is owned 50% by Kongsberg Defense and Aerospace, a division of Kongsberg, and the other 50% is owned by Space Norway, a subsidiary of the Norwegian Space Agency, in turn of a government agency under the Ministry of Trade, Industries, and Fisheries here in Norway. So, what are the main business areas? KSAT is organized in 3 of those main business areas: the ground network, Earth observation services, and government programs. So through our global ground network, we are perfectly positioned to provide near real-time services to both institutional and commercial customers. And we also have a strong market focus on continued investment in technology, business development, and strategy, so that we continue to build for the future. So the US is our largest market, followed by Europe. We have a small but important home market here in Norway, while Asia is growing fast. The 2 main business segments, ground network services and Earth observation services, comprise about 87% and 13% respectively. And our staff has a high level of education within the STEM fields as well. We're also big into corporate social responsibility. It's very important to us, and we emphasize quality, security, and compliance in all aspects of our operations, as well as focusing on the supplier chain. And KSAT is committed to use our resources and competence to make a positive difference for the environment and the community we live and operate in globally. Okay. Let's dive a little bit more into the ground network services here. So we provide ground support throughout the whole life cycle of a mission, from the critical operations during launch and early orbit phase. And our global ground network is positioned to support any mission from LEO to all the way to lunar missions. Okay. So we offer standardized solutions for small satellites and big constellations, as well as tailored solutions and large aperture support, and we can solve all your ground network needs. And we're also expanding these services further by adding optical communication capabilities. Going into Earth observation services, we are specialized in delivering time-critical data and derived information to a broad range of end users. And across multiple satellite missions and sensors, we can solve your information needs as well. Having pioneered the maritime monitoring using synthetic aperture radar, SAR, right, for more than 20 years, we're now offering forestry and land applications, as well as a range of environmental services using optical data. And of course, KSAT, we are in the forefront when it comes to development and implementation of new technology. We have developed and deployed an industry-leading software-defined ground station architecture, enabling easy integration with any public cloud platform provider or highly secure private cloud for efficient transport, processing, and storage of space data, as well as investing significant resources into the machine learning and AI development. So KSAT's headquarters, where I'm actually now, I've been here for a few weeks and shall continue to be here for the next a couple more weeks, is located in Tromsø, Norway. Space, and it's at 69 degrees north. And some of the unique ground stations that we have that I'd like to just cover today briefly are Svalbard, which is at 78 degrees north, almost at the North Pole. It is recognized as the best located polar ground station as it provides access to every orbit for spacecraft operating in sun-synchronous orbit. With its 124, soon to be 130 antennas, it is the largest ground station in the world, and it shall continue to grow. Next, we have Troll, which is our Antarctic station, and that's located 72 degrees south. It is the only commercial ground station in Antarctica, and it provides access to almost all orbits from the southern hemisphere. Troll, in combination with our Svalbard ground station, provides connectivity twice per orbit for most polar orbiting satellites, also called pole-to-pole. And here is just a map of our global ground station network, which consists of more than 200 antennas at 25 select locations, and it is continuously being developed to meet new customer demands. So just to wrap up, in case that we know what it takes to deliver the top quality services every day, and we fulfill our customers' requirements with regards to security, proficiency, timeliness, and quality is our main priority. The KSAT spirit is all about exploring new ways to create value for our customers. So seeking different solutions and utilizing new technologies is an it's an operationally challenging environment, right? So we adhere to international standards for quality and security, and we have operated ISO standards for many years as well. So with that, thank you once again for your time and listening, and if you have any questions, you can very much ask them while we're in the breakout rooms. So thanks once again.
Ruben, thanks a bunch for going over capabilities of KSAT. Telecommunications, as mentioned here in the chat throughout the event today, and our conversations at Arkisys, is a critical element to successful missions, everything from science to achieving novel paradigms in space. And so I really do second that, to go connect with Ruben in the breakout room and answer some questions that you may have about KSAT and its capabilities supporting the ports ecosystem. All right, up next and last but not least, Julio is a CEO of a startup, Stampede. They work on a series of different subsystems and power systems. And I'd like to hand it over to Julio to round out our presentations for the day. Do hang on for the breakout rooms. I'll give everyone a chance to join them after Julio has completed his presentation. I'm handing it off to you, Julio.
Thank you very much. Thanks a lot for this great opportunity, and thanks a lot. Can you hear me well? Can you all hear me well?
Yep.
And I'm going to share my screen. I'm going to see if I have enough bandwidth, not just hoping. Dan, and let me know if you can.
Sure thing.
you can help me with that. So can you see my screen now?
Yep.
Hold on a second, please. So you can see my screen, right?
You do. You may need to maximize your presentation.
What I just did. Sorry, I'm going to stop sharing and share once again. There we go. Sorry. Can you see it now? Sorry. All right. Hello, everyone, and thanks for opening today with us. My name is Julio Batista, and I'm here to talk about XMP and also how we contribute and can integrate our products, and not only our products, someone else's brands into the spaceport of Arkisys. We have recently incorporated our space startup in the UK. We are developing power, conditioning, and distribution units and onboard computers, OPS, in other words, power and computer systems for new generation spacecrafts. Well, in this forum, everybody knows what the new space is the disruptive commercialization of space. And well, just to give you some numbers, just in this decade, in only 10 years, 5 times more satellites will be launched than the previous 60 years of space history. This is the market status quo. And there's going to be many opportunities, of course, and a huge growth in this market from now on. One of the main reasons why we launched our startup is the high failure rate of small satellites. 40% of small satellites fail in orbit. And one of the main reasons is the lack of reliability in the design process of a spacecraft. And that makes a lot of sense for a project like Arkisys to provide repairment, refurbishment, and in-orbit servicing for space vessels. Another reason for launching our project is that mission requirements demand satellites to be customized or modified. Customization is very expensive, and development time of that customization may cause mission delays. We provide our customers, the satellite integrators and space companies, with the best customer experience in their space missions because we help them reduce risk, cost, and get on time for the launch of their space vessels to space. We supply them with high reliable and modular space systems. Our systems or products are smart because there is a computer in each module, cost effective because we use selected low-cost components, assuring those will work in space environment, and adaptable to all missions. Talking about a little bit about us, we are a team that has been involved in more than 30 successful space missions. We have over 15 years of experience in the space industry, and we have developed several space products, which over 100 of those are up there on a mission and in orbit as we speak. And we pride ourselves on our track record of 0 in-orbit failures. We have experience in the design and development of different types of satellite systems and subsystems. We have designed and tested over 50 power systems for nanosatellites and for different types of small satellites in the case of GeoSat and different power needs for small satellites, as I just said. And we have the experience in the design of different power topologies for the maximum power transference, of course. We have developed digital systems, and over 40 satellites use our onboard computer design, and more than 15 satellites use our attitude and our orbit control system. This would be the traditional power system architecture of PCDU. The energy is taken from the solar panels, then is processed to and sometimes from the battery, and then distributes the rest of the satellites, the energy to the rest of the satellites and systems. And here's one of our key differentiators. We have 2 technologies that can be patented, and we can add modules very fast to increase and have more power, computer capacity, and redundancy depending on mission requirements. And here is where you can see it's next to the interface of the color, and that color is the interface of Arkisys. There will be 2 ways to have power and data transfer for space vessels with the spaceport. One is through our power and conditioning and distribution unit, which I just said is going to be a module already integrated. And on the second case, a Nexus module will be attached to a vendor's PCDU. So when a space vessel needs some repairment, refurbishment, or whatever the service is needed, like for example with Volume Scientific, some experiment done there, through the Nexus interface, you can have a transparent data and power transfer. So the Nexus interface is at the very core of the solution. It provides a certified, robust, and protected power and data interface between the guest satellite, the guest space vessels, and the spaceport. With the following services, there's going to be a power transfer. The Nexus provides regulated and controlled power transfer from and to the port. The Nexus also provides protection against transient and permanent faults, including overcurrent, surge, thermal, shortcuts, short circuits, and under and over voltage, for example. An integration to host satellite PCDU, like I just said before, the Nexus can interface to a third-party PCDU system. It does this by sourcing and dumping power to and from the battery bus. The Nexus will also implement a current limitation. Then, for example, a native host PCDU, in the case of our PCDU, in this case, the Nexus is an integral component. This will provide the smallest footprint possible and is available. It will be available on a single or dual redundant module system, which can it could accommodate power systems, for example, for sizes up to 2 kilowatt and beyond. There's going to be a control, telemetry, telecommands. Command control interface is implemented such that the host computer can control the operation of the Nexus and monitor the state of the system. In this case, it will include a control power that transfers in each direction, as well as monitoring instantaneous and total power, the current and voltage measurement as well. There's going to be a handshaking, of course, to integrate with the spaceport. The Nexus will take all the necessary actions to handshake with the spaceport in order to request power or to offer power into the spaceport when available. This ensures that the power delivery to the into the host can take place anonymously, even without an onboard computer intervention. For more protection, there's going to be a galvanic isolation. These will protect against any possible failure conditions. Both data and power are galvanically isolated. So the Nexus can be passivated upon the telecommand. This will ensure that the host and the spaceport will be protected against permanent failures and aging hardware, as well as complying with NASA and ESA requirements protecting the systems from possible overcharge and venting events. Of course, there's going to be a full communication bridge. The Nexus implements a communication interface which encapsulates all the host communication interface and packages from routing via the spaceport communication services. The Nexus processor can implement a configurable and bespoke adaptation layers to interface to host native communication protocols and physical media, which includes, of course, CAN, Ethernet, SpaceWire, RS-422, amongst others. And last but not least, a hot insertion and break. The Nexus provides connection from hot insertion and live disconnections which may occur during coupling maneuvers. This is pretty much about the flavor of the Nexus, and we are very excited about this project and provide connections to the spaceport, this great project from Arkisys. So that's why we invite you to become a part of this exciting era of the new space with a company that has a lot of experience in the space industry as Exampede, and of course, partnering with Arkisys. Thank you very much for listening.
All right, and that concludes our presentations today for our keynote speakers. Please give everyone a round of applause as I get ready to let everyone into the melee that is breakout rooms. Thanks a bunch, everyone. So.